Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm Holly Masretini. I'm from Srijaya University of Palembang. Today I would like to present my paper with the title Chemical Oxygen Demand Removal of Pulp and Paper Wastewater. Rapid advance in the industrial sector have resulted in an increase in toxic pollutants being released into the environment. The paper industry is one of the third largest water consuming industries after the metal and chemical industries and ranks sixth in major environmental pollution. The wastewater produced is highly concentrated and has a wide range of chemical oxygen demand values due to the different types of substrate used, such as softwood and hardwood species, paper recycling, and etc., and the types of pulping and paper making process. The chemical oxygen demand value is important wastewater treatment as it represents the amount of organic pollutants present in wastewater. That's why it must be processed properly in order to meet the environmental quality standards set by the government. The objective of this research is to investigate the performance of the Fenton process on chemical oxygen demand reduction and obtain the optimum condition in treating the pulp and paper industry wastewater. Fenton method is a part of advanced oxidation process, a technology used to oxidize recalcitrant compounds that are difficult to degrade by biological process. The mechanism of advanced oxidation process involves the formation of reactive oxidizing species, hydroxyl radicals. It can achieve partial mineralization, turning them into more biodegradable substance, or even complete mineralization into an organic substance. Fenton method is a practical technique to produce hydroxyl radicals at ambient temperature and pressure. It is produced when iron 2 reacts with hydrogen peroxide. The material used in this study are hydrogen peroxide, iron sulfide, heptahydrate, distilled water, natrium hydroxide, sulfuric acid, and natrium thiosulfate, and also pulp and paper wastewater effluent taken from the equalization tank. Determination of optimum condition was carried out by taking 500 milliliter of wastewater samples and adding iron sulfate heptahydrate, followed by pH adjustment by adding sulfuric acid and natrium hydroxide. Homogenization was carried out at 200 RPM with a magnetic stirrer for 60 minutes. The reaction was started by adding hydrogen peroxide, and after 60 minutes, natrium thiosulfate was added to stop the reaction. Next, the sample was analyzed for chemical oxygen demand reduction by spectrophotometry method. The chemical oxygen demand value of wastewater produced from the pulp and paper industry does not meet the environmental quality standard. It is reached 949 milligram per liter. Result and discussion. Effect on molar ratio on chemical oxidation reduction. The optimum of Fenton reagent to degraded pollutant contained in pulp and paper wastewater is at molar ratio 1 to 1000, where at this molar ratio, chemical oxygen demand is reduced from 949 milligram per liter to 114 milligram per liter, as shown in the figure. The chemical oxidation demand decreased significantly, but at a molar ratio of 1 to 1500 until 1 to 2500, there was no longer decrease in chemical oxygen demand because it was likely that the wastewater was no longer degraded by the Fenton reagent. In the Fenton process, wastewater was no longer degraded by the Fenton reagent. Hydrogen peroxide plays an important role in degrading organic compounds. Increasing hydrogen peroxide concentration should increase the efficiency. However, the use of hydrogen peroxide in excessive concentration will cause OH scavenger, where hydroxyl radicals react with other compounds that have weaker oxidizing power and can reduce the number of hydroxyl radicals to break down organic compound in water. Removal efficiency. The treatment of pulp and paper wastewater with the Fenton method shows good treatment efficiency. The reduction efficiency occurs in all varied molar ratio and the value has met the environmental quality standard. However, the best reduction efficiency was obtained at a Fenton reagent molar ratio of 1 to 1000 with a COD reduction efficiency of 88%. and it can be concluded that the Fenton method used in this study is able to reduce pollutant levels in wastewater and achieve a reduction efficiency. Comparison with various pulp and paper wastewater treatment methods. Several effective wastewater treatment methods have been carried out to treat pulp and paper wastewater. Absorption, coagulation, advanced oxidation process separately or in combination. In the treatment process with the Fenton method with heating carried out by Yani using the same waste source, the COD efficiency reaches 82%. And also the research conducted by Gautam with the Fenton method achieved an efficiency of 88% with a different wastewater source from the discharge of the bleaching process. COD reduction with several treatment process combination achieve efficiencies ranging from 50 until 1990.1%, depending on the source of wastewater treated and the process used. From the result of the research conducted, COD removal reaches 88%, and the Fenton methods is effective for reducing COD in pulp and paper wastewater treatment, even without a combination with other treatment methods. The conclusion: the Fenton method is an effective solution for the treatment of wastewater from the pulp and paper industry, especially in chemical oxygen demand removal. It reaches 88% efficiency by molar ratio of 1 to 1000, steering speed of 200 RPM, and pH 3 for 60 minutes, resulted in a significant reduction in contaminant levels. Okay, that's all for the presentation today. Thank you for the attention and have a nice day. Wassalamualaikum warahmatullahi wabarakatuh.